we did a specific exercise to predict sales. But again, as a reminder, these embeddings are multi-purpose. So we decided to run this test to predict sales. But again, it could be also used for predicting some socioeconomic index, some health index, also retail sales or real estate prices, for example. The exercise that we are going to be doing here is, well, actually two exercises. This is part of a broader test or exercise or initiative that we ran, that you have all the details in CARTO's blog, in which we wanted to compare the predictive power of socio-demographic data versus embeddings versus the combination of both data sources. So I'll show you how we can build such a model in CARTO Workflows. And then we'll discuss a little bit of what are the results, what are the type of insights that we can get, how they compare to one another, and you'll see how this becomes a richer analysis, and all that I just explained before now makes sense. So as we were saying, in this case, we're going to be using this Iowa liquor sales. This is an open data that is publicly available. Let me quickly show you what this data contains. So basically we have every single item, so alcoholic item that was sold in Iowa is recorded here. We know the item, we know the location, we know the store, and we know the price, we know the volume, etc. We're just going to keep it simple. We're going to aggregate this at the zip code level and use the PDF embeddings at the zip code level. But just so you know, we have all this detail. Then for socio-demographics, we're going to use socio-demographic data from ACS, so American Community Survey. Again, here we have plenty of variables from population by age and gender. Then we have income, for example, here per capita, median income, income by range, etc. Okay, so you have plenty of data here that we'll use to try to predict these sales. And then finally, what we would like to do here is combine this with the Population Dynamics Foundation model embeddings at the zip code level. So here in Workflows, we have this package called Geospatial Foundation Models right now, as we said. So we have the AlphaEarth and PDFM embeddings at the county and zip code level. So in order to integrate this into your analysis, you just, again, drag and drop, and you have it here. Once you have the embeddings in your canvas, you can explore what these embeddings look like. And again, for every zip code, well, we have different information about the zip code, like the name, population, and so forth. But then we'll have all these 300 features that Gotham was explaining before. I'm not going to get into the details of everything that you can do at Workflows, because that's not the purpose of this webinar. But basically, again, since this is an analytical tool, so we can just transform the data, group it, and etc., so that in the end we have data that we can actually combine. So with social demographics, since we have it at the zip code level, we don't really need to do anything. Liquor sales, we have it per day and store, so we need to aggregate it at the zip code level for the entire 2022. We selected 2022 because most of the data sources used for the PDFM embeddings model are from 2022, so that's why we selected that year. And then with the embeddings, again, we don't need to do anything in this case because they are provided at the zip code level. So once we have this data ready, we are able to train our model. In this case, for training our model, we're using another extension package at CARTO, the BigQuery ML for Workflows, which is a set of 12 components here that allow you to create classification, forecasting, regression models, and then to evaluate your model, to get feature importances and so forth. And these are wrappers on top of BigQuery ML. So you have the capabilities of BigQuery ML, but again, in a no-code approach. Okay, so you just drag and drop a component, you configure it, and then you can run your analysis. So again, not the purpose of this webinar, I'm just going to go to the very specific on how we built. In this case, we are combining all the data sets. So we are building a model. Let me show you here. So we want to predict total sales per zip code, and we are using both sociodemographics and the embeddings. Again, this is part of a broader initiative. If you wanted to just run it with the PDFM embeddings, well, you would disconnect the sociodemographics. If you want to run it only with the sociodemographics, you disconnect the embeddings from the workflow, and you can compare the results.